Not accepted.
So guys, everyone, hello and thank you for coming. Today I will be telling you a story. So I would like to tell you a brief story of a journey that we went to past couple of months or maybe a year or so. And the story will be about how to use a metrical approach, which is normally used for system or infrastructure in a more business way. So how we can detect operational outages, issues using metric approach, metrics and alerting, dashboards, etc., etc. So this is a bit different context, but still a very familiar for many of you attitude that you probably use in your daily work. So first of all, let me introduce myself. Who am I? So my name is Adrian Gonciarz, and I work for Kitopi as a QA and as a SRE director or lead, whatever you want. I have a team of 14 people at the moment, mostly QAs, but my second leg or the second branch of activities is SRE, which is site reliability engineering. This is a fairly modern or rather young branch of knowledge. And if you don't know what this is, I'll say two words in a second. First of all, I have mostly QA background. I've been in IT and QA stuff, so to say, almost for almost 9 years now. It's been pretty intense time. I gathered some knowledge. I met some amazing people. I was able to work with great guys with whom I'm currently also, and again, working in Kitopi. But aside from my QA background, as a QA engineer, test automation engineer, QA lead, I also have the second branch right now, which is SRE. I'm focused on looking into the system or looking at the system from the perspective of outages, issues, how to detect them, how to make our system more reliable. And actually, I'm lucky enough that my QA team or the QA branch, QA people are very mature, they are very independent. So I don't have to like micromanage. I don't have to, sit by their at their desk and look what they're doing. They are super professional people, and mostly my activities revolve around SRE right now. And this will be the topic that I will be working on today. As soon as my okay, great. I'm also, I would say, automation head. That doesn't mean that I only focus on test automation. I like automate stuff, I don't like doing manual things. I don't like to do the same thing twice unless it's super, necessary. So I'm into infrastructure as a code. I'm into automation pipelines. If you can do something by script, by GitLab, that's where I live, basically. So I like automating things, I prefer startups over corporations. I don't tend to bound with big companies. That's why mostly my background is in a quotation mark startup, but I prefer smaller companies. Even though Kitopi is over 2,000 people, the engineering team is around 100, and we are based in Krakow. I'm also, I would say, a teacher. You can say coach, mentor, doing presentation, being a lecturer in the university, whatever. After all, it's a teacher. I like, teaching people, working with people and seeing how they grow. So that's why I also learn many things as I teach others. And I'm also a hobbyist. As you can see, I climb, I play guitar, so I'm not that boring after all, even though you might have a different outlook after this presentation, hopefully not. Let me tell you two words about Kitopi. Kitopi is a, let's say, we used to say cloud kitchen, but right now we are, let's say, a multi-brand kitchen platform, okay? What does it mean? It means that we are basically working with food. We are basically working with many activities related to food preparation, ordering, deliveries, and stuff. So amongst our operations, they're managing products and ingredients. So basically, sitting in a warehouse, I need 100 kilo of chicken fillet, I need, corn, etc., etc. Yeah, this happens in so-called central kitchen in Kitopi. So we start with managing our ingredients. We are also building menus for our restaurants, which with we are working. Then actually the most important part of Kitopi is ordering. We take orders from different sources, directly from our customers, from people in physical locations, but mostly from so-called aggregators. Aggregators are third-party websites. You can think about like Pyszne.pl, okay? This is a kind of aggregator that we are working with, and most of our traffic, most of our orders is coming from this aggregator platform. So if you hear aggregator, you can basically think of Pyszne.pl or a big website that has multiple restaurants. So there are multiple sources, but where the money lies, is that we are taking orders from customers. So if you want to order sushi, after all, and you are in Dubai, after all, there is a strong chance that your order will get to Kitopi. We are actually preparing meals. So like a big part of our physical operations is meal preparation. Actual kitchens with actual stations where they prepare pizza, your sushi, your whatever you order, like different foods. Even if you order from some famous brands, there is a strong chance that we are preparing your meal. That also means that the meals that we are preparing, they have to be on par with quality and the taste as you will get it directly from the restaurant, right? Then we take care for your deliveries. So if you order, your meal is prepared, and then we need to deliver or somehow order a delivery for you. This is also on our shoulders. Then sometimes the restaurant might be unable to process your orders. It might be closed, do some outage, or just basically we run out of ingredients. So we need to open or close a particular restaurant. So we basically manage also the ordering channels related to restaurants. And finally, we deal with customer service. Your food is cold, the driver is not nice, the delivery is very late, there is something wrong with the food, we deal with customer service. So basically, if you are a restaurant and you integrate with us, we take care of most of your operations, from ordering ingredients to dealing with customers. So this is a bunch of activities that you have to take care of. So if you think about these operations, you can think about possible metrics. You know what is a metric? A metric is basically a number with possible dimensions that hold some information. So already from this description, can you come up with some metric that could be applicable in this situation? Sorry? Delivery time, great idea. What else? Wasted ingredients, great idea. I didn't think about it. Okay. Anything else? What would be the most important metric if I told you that, where the money lies is ordering? Customer happiness, sorry? Successful payments, but, that's it. So the most important metric could be like the number of orders. How many orders daily we are taking per country? We are dealing with, Kitopi is operating in Middle East. Kuwait, Dubai, Saudi Arabia, few countries. And also in those countries, we have different aggregators. So we have, the most important thing is how many orders we get for country and for aggregator. So that would be number one. Then also important metric, how many of orders incoming to our platform we reject. Sometimes the order that is coming to our platform is not valid, improper. There is missing ingredient, there is the dish that you order is not available, any other problems, or the structure is invalid. How many orders daily we reject? Also, how many of them we cancel, we or someone else? So imagine that you've been waiting for your meal for 2 hours, the driver didn't call, you are angry, you call our customer center, sorry, I don't want this meal anymore, we cancel it. Or maybe, there was any other reason. So we also want to be on track with canceled orders. You mentioned delivery time. Actually, also important metric is for how long a particular restaurant would be closed. So we are also we could track the closing time of our restaurants. How many deliveries failed due to also certain reasons. So you see that these are numbers that hold value, but the value of a particular number means something in a context, right? So for orders, we have country and aggregator, which we would call, for a metric, as you probably know, a dimension, right? So in failed deliveries, for which delivery partner, or for which, area, or for which reasons. So those numbers are important, but also keep in mind that all the metrics mean nothing without a particular context, whether it's a business metric or it's a system metric, as you probably use currently. And also important thing that we introduced lately is the error rate of third party. So not only some data or orders are coming to our system, but also we are getting some information from the aggregators directly, querying them, sending requests to them. And also we can track this information, so see if we are, basically communicating with them properly, or is there a spike on errors, for example. So these are metrics, If you are familiar with metrics, Prometheus, Grafana, you see that, even though the context is more business oriented, the attitude is the same, right? This is the error rate, this is the number, this is the time, etc., 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 okay? So let me tell you 2 words about our tech stack. There will be no big surprises, no, unknown technologies. We start with AWS. We are a cloud-based platform. And then on top of, on top of that, we have Kubernetes, so EKS. Also no big, surprise here. Our system is Kafka-driven or data-driven in the sense that most of the information is propagated amongst microservices via Kafka. For those who are familiar with Kafka, you already know what this is, but in a second I will tell a bit more about Kafka information sending. For you, just to have a background, this is a way that we propagate messages in between microservices. And again, we are in microservice architecture, so no big monoliths. Which also, evolves as we learn about our domain, because we have to, rework our system from time to time. In the beginning, as for metrics, for tracking information, we had Grafana and Prometheus, which is familiar, common metric stack that probably many of you use, also open source. But last year, we introduced a tool that's called Dynatrace, which is more commercial tool and does what Prometheus and Grafana does. So metrics, dashboards, etc., but it has many more features. So it's able to detect anomalies, automatically detect traces, help us with debugging, the root cause analysis, etc., So this is a more complex tool, but you can think, in terms of this presentation, you can think about it like an extension to Grafana and Prometheus, something like this, but plus. And at the end, we are using Slack, which is just a node, but we are using that also for messages that being sent for alerts. So, as I said, in our system, information about different changes, for example, changes about order status, restaurant, etc., are translated into Kafka messages. So if you want to know that an order has changed status, restaurant has been closed, the delivery failed, etc., you could basically fetch this information from a message that being posted, posted on Kafka topic. And from this, maybe you could get an idea. Okay, so if I already have this information, I don't have to, add this to anywhere. So maybe there could be a way to aggregate this message, aggregate those messages or work on those messages. And knowing that, would there be any idea that maybe you could come up, like what to use to aggregate messages on Kafka topics or work on that? A tool or framework? The tension rises. Okay, so it's Kafka streams. Many of you might be familiar with the idea of Kafka streams. I'm not. No, just kidding. I'm not an expert in Kafka streams. Kafka streams is something that works like this, more or less. So we have an input stream. So that would be messages that being, asynchronously, constantly posted on some Kafka topic. So you can think of Kafka topic, if you don't know anything about it, that's a stream, a river, where some small animals are throwing messages in a bottle. So these are the messages, okay? And as we go along this stream, somewhere in the middle, we are putting a processor. So we are putting a thing that's gonna look at these messages, read them, and aggregate them. For example, we can aggregate all the messages that are related to this restaurant in one place in a so-called state store. State store is just you can think about it as a table. So we are holding some, state for particular keys for some longer period of time. So we are basically processing or fetching these messages, aggregating them here using a processor and some state store. And after a period of time or some condition has been met, we are outputting aggregated messages to some downstream. Okay, somewhere downstream, so basically to some another topic. So for example, if you had, page visits here, you can aggregate every 10 minutes and see every 10 minutes post, okay, last 10 minutes we had like 200 visits. Last 10 minutes we had 500 visits. If you want some more information, you can keep some dimensions here. For example, you can read all the page visits and keep all the visits for Poland, here, 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 and every 10 minutes output Poland 10, Germany 5, etc., etc. Okay, this is more or less the idea you need to keep in mind when you are thinking about this solution here. And in our solution, or in my solution, I'm not a Java person, unfortunately, or fortunately. Piotrek is smiling. No, I'm a very simple person, so I use Python. And Python has a similar implementation to Kafka Streams, which is called Faust. Faust is a library that has very similar interface and all the functions that Java Kafka Streams has, but we are able to use that in Python. That's just a side note for those of you who are not writing in Java, but still you want to use Kafka Streams. I recommend this one. I recommend a fork, which is called Faust Stream, because the official library is not, or the original library is not well maintained, and it has some bugs. So Faust is the name of the library, but I recommend the fork, Faust Streams. Okay, so let me tell you about the proof of concept. We had to choose something because, we wanted to see, as we started developing our so-called command center. So command center is like a place between the development teams and first lines of support. So they are, keeping their the hand on the pulse of our operations. So they would like to be able to easily see what's going on inside the system, but not from the system perspective, more from the business perspective. So we had to choose something for proof of concept, and we chose the closed restaurant or restaurant closing time. So for us, sometimes we have, as I spoke before, we have to sometimes close a particular restaurant, and sometimes we literally either forget to open it, or we have so many closed restaurants that we don't keep track on all of them. And we are not actually, without this information for how long a particular restaurant has been closed, we are not able to tell if there is a bigger issue or not, because, we don't have anywhere this information. Maybe we can go somewhere on the UI web page and look at the numbers, but it's not, it's not easily visible. I need to know exactly at this point of time how many restaurants are closed and for how long they have been closed. So in our case, I'm not sure if you see it, but on a Kafka, upon closing opening a restaurant, we are producing an event which contains the status, whether we are opening the restaurant or closing it, and some timestamp, and of course the ID, the name of the restaurant. Okay, so each time the restaurant has been opened or closed, we are changing its status and sending a message on Kafka. So when we are processing on the stream, every time we are getting the closing messages, we are putting the status of this restaurant with its timestamp to the table, this store table, table store, the state store that you have seen previously. Okay, so we are keeping the track in our processor of when the restaurant has been closed. And every 1 minute, we are aggregating, or we are going through the table, and for each restaurant that has been closed, we are producing a message. Okay, this restaurant has been already closed for 1,500 seconds. Seconds are okay, because seconds are quite a good resolution. We could also use minutes, but second is a good unit. So anyway, every 1 minute we are producing a snapshot of the table, right? Restaurant names or IDs, and the time that there has been closed so far. Also, when we get a message about opening the restaurant, we are deleting this record, so we are no longer producing the message. This is a super simple mechanism, right? And after that, we are producing, or we were producing these metrics directly to the source, to the Dynatrace, which is, as I said, as a metrics management system in this case. So we are producing these metrics and we are able to visualize that. So if you think about it, it looks like this. We have a table, we have messages coming on, okay? This restaurant has been closed, okay, put it to the table. Okay, sometime later it has been open, so delete this record. So we are working on a, semi-persistent table where we put the records, and every 1 minute we send the aggregation to Dynatrace. Okay, this restaurant has already been closed for 1,000 seconds or 5,000 seconds. Okay, you get this? Should be simple enough. But if you think about it, what kind of metrics is that? What we just implemented? We implemented a simple counter, right? This is nothing else than a simple counter, which is just basically, counts the time since some event has started. This is not a persistent counter like, for the whole life of application, but just for a simple restaurant within a day or maybe an hour. So we have this counter. So this way, I'm sorry I had to blur out the restaurant. I don't want to spoil any company secrets. But here you can see that after this, we can see that some restaurants for some kitchens has been closed for, 13 hours. And then you come first time they saw it, they were like, what? Now all of a sudden you can see that a particular restaurant in a particular kitchen has been closed for some longer period of time with some reason. Also, we have some reason why this restaurant has been closed. And now on top of that, you can add some alerting, or you can build some tables. Okay, for those reasons, for those restaurants, I want to have it. I want to be alerted if it's closed for over 1 hour, let's say. Until you did that, until you visualize it or put it in the metric, there was no way to do it. But if you think about the first solution, if that was the only business case that we wanted to solve, that would be okay. We could put it. Basically, it was one small microservice written in Python, deployed on Kubernetes. So this one microservice was reading messages from Kafka topic, aggregating and producing. So it was basically responsible for everything, good or bad. Is it okay that one microservice is responsible in this business case for reading, aggregating, and producing metrics? Someone said it depends? In my opinion, it depends. If that was the only problem we wanted to solve, and it was well written, well tested, I wrote it, so I wouldn't say so. But if it was well written, well tested, it was the only problem, or maybe we would like to replace it later with something more, basically better, so maybe Java, it would be okay. But in this case, we wanted to solve some more problems, basically. We wanted to have more metrics. And in this case, we wanted to read from different topics. We wanted to make different aggregations. So if we follow the same pattern, we would have, many microservices that would do the same, basically. Read from topic, aggregate, produce, right? The same. If you think about it, there are some improvements to be made to this skeleton, okay? So first of all, we need to split the responsibilities. One single microservice should not be in this, what we know right now that we want to solve many problems, should not be responsible for aggregations and production, right? So export. If you think about it, the sources and the way we aggregate will be different, but what we want to produce is basically the same. It's a metric, right? Metric with dimensions. So what is a metric? Again, this is a number with some dimensions. So number within a context, okay? So first of all, let's split those responsibilities for aggregations and export. So we will introduce the processors, like small services that are responsible for streaming. And then we will have aggregated data produced by those processors to intermediate topic, where we have some particular schema. And there will be another microservice, or rather another place in our architecture, which will be reading from this intermediary topic and sending those metrics to the, to the cloud, basically, to Dynatrace. So I made this beautiful diagram, which is not super easy to understand at the beginning, but I hope I will explain it. So here we have some microservices, like actual microservices application in our system. So I don't know, the kitchen core, delivery core, whatever you call it, like we call it kitchen API, delivery API, etc. So actual applications, which are producing those informations about state changes to topics, to Kafka topics. And these topics are sources for our processor. So this could be the topic that has information about closing or opening the restaurant. The processor reads those, or streams the information here and aggregates every minute, then produces a message about metric to some intermediary topic. And then we have a thing here, a thingy. I will tell you what this thingy is. Which is responsible for reading messages from this formalized schema topic and sends it away to Dynatrace, okay? So then if we want to introduce another aggregation, another business context, etc., we just introduce another processor. Another nice thing is that if we don't have this information here in these topics, we can put something here that produces the information. For example, I will tell you in a second about so-called KDS heartbeats, where you don't have to exactly have any information on topic coming from the application microservice, but you can build some simple gateway and some Lambda code, and it's going to be okay. Here, we did something very nice because we use the AWS Lambda, which is reading from Kafka. We are using MSK, which is Kafka on AWS. But basically, this thingy here is a Lambda, where you know what Lambda is, right? This is like let's say, a function which is invoked on every event. And those events are basically the batches coming from Kafka streams. So this is nice. In Lambda, you don't always have to use events like crons or API gateway calls, but you can also use source of events, which is some Kafka topic. If you have MSK, right? If you have this implementation of Kafka implementation on the AWS. So basically, you see that here you have the layer of producing business data, like state changes. Here you have the layer of aggregations or processing, and here you have the layer of exporting this data. So this will pretty much never change unless there is some changes in APIs or schema, but this can be extended, scaled up as much as you want. So upsides of this solution, just to recap, you can have easily replaceable processors. So if this is written in Python, if someone decides to write it better or different, or the bus hits me, someone else can come and replace it with Java, C#, whatever you want, right? We're not using C#, but you can replace this single block and it will be okay, right? So we can replace one single processor here. Scalability, as I shown you, the processors can be moved, basically in this case, vertically, but effectively horizontally. There is one single communication bus for metrics. So all the processors are producing the messages according to some schema. Even if you don't have processor, you can do it manually, like just post from your own application to this communication bus. So if instead of using micrometer, we were using some piece of code that would be directly sending to Dynatrace metrics topic, it's also okay because it's gonna land there eventually, right? And if you want to add another source, not before processors, you can do it. I will show you in a second. So let's take a look at another example, another business example, okay? Which in our case will be incoming orders. So first of all, let me give you some background. Our orders have many sources. It can be mobile, API, web. We can add whatever we want. Even if you would like to send us via Kafka, it would also be okay in some particular context, okay? We have 5 countries, over 10 aggregators, over 60 kitchens. I'm not sure about this number of kitchens, probably it's more. And God knows how many restaurants, okay? So this is a big, big number of possible dimensions, right? If you think about dimensions. Volume of our orders is like somewhere between 20 and 30,000 daily. And my estimated rejection rate, so whether it's a problem with some integration or whether there is a problem with schemas, we have around, let's say, 0.25, 0.5% of rejection rate. If you calculate it, this translates to maybe 100, 200 rejections daily, not more than that, okay? So you have a huge amount of orders. Oh, sorry, big data, guys, but this is a big order for a big number for us. Anyway, like 20, 30,000 is a substantial number, okay? And rejections is like a smaller number, okay? And if we think about the metrics that we can produce from that, we will have the created orders, which is a bigger volume, but we don't have such a huge resolution. Okay, so maybe we want to aggregate every 5 minutes. We don't need all the dimensions, all the kitchens, restaurants, etc. We only want to have dimensions of country and aggregator. So this is a metric which would have a higher value, higher value, but will be aggregated less frequently with less dimensions. Okay, and the other metric for a comparison would be rejections. Okay, where we have more frequent aggregations, 1 minute aggregations. And we also want to have more dimensions, okay? Where exactly this rejection happened, for what reason, right? In which aggregator, kitchen, restaurant, and for what reason. And this will be, smaller numbers, but they have a lot more context to it, okay? So if you take a look at it, this is a graph of order number distribution. This is actually where our metrics were not working, for whatever reason, don't ask. There is a gap, but normally we have, let's say, this number of orders. Here we had, I think, Ramadan, which is in Middle East, a place where you basically drop a bit in your orders and the traffic of orders changes significantly. You don't see it in this graph because this is a longer period of time, but now you can see that we are able to, at first sight, easily track number of orders as a metric within the tool. So if you take a look at order distribution for countries, we have different countries, and you can see that mostly the shape is similar. People are ordering for lunch and for dinner, but there is one country which is UAE, Emirates, which dominates, and there are some countries where we have less and less and less orders, okay? You can also, have this measure for something. And also, I know this is not super easily readable, but you can see that within like 24 hours, there are moments, or maybe when we have the highest traffic, there are some rejections. And some of these places are important for us. What do I mean by that? For example, probably here, we had a place, one single color represents one single kitchen, one single aggregator. So basically the same place in the map, let's say, and the same reason. So at some point of time, we are getting rejections in a same physical place or same physical kitchen for the same reason. For example, I don't know, there is cold food. Maybe someone is, that's gonna be rude, but maybe someone has worst day and is not doing food good, right? And this is something that no system will detect. But this kind of metric can detect that because you have post factum business information. From this place on the map, from this kitchen, we get many rejections, or maybe in this case would be cancellations, but there is a problem. You can pinpoint the problem. There is a problem in this particular place. You will not get it from the system, but you can easily see it in the business metric, right? So let me give you an example of another metric. Kitchen heartbeat. So how it looks like. We have many, many kitchens, physical locations where people work. So people work on stations. There are cooks that are working. This one is working on sushi. This one is working on pizza. This one is working on burgers. Like really kitchen, right? You can imagine that. Now you have like 60 or 100 of these all around the city or a country or some particular area. These people get their orders to prepare or meals to prepare on some called KDSs. And each kitchen has multiple of this workstation. Basically, you are a kitchen, you have your table here, preparing sushi. On your screen, you see, okay, there's another meal I need to prepare. I'm preparing sushi. Click, it's done, okay? This depends on internet. This also depends on power, right? Electricity. We are not thinking about this like, things like electricity, internet, water, heat, and trust me, the heat is huge. We are out of the boxes, we are out of the, I don't know, rice, etc. Like, our problems are like the coffee is out. Their problem is like, I'm working in 45 Celsius degrees and the AC is off or electricity is off. Trust me, you don't want to be there when something goes wrong, right? You will not see this kind of problems in the system again, right? So we came up with the idea, what if each workstation would produce a heartbeat to our system twice a minute? Why twice? Because, statistically, if we bucketize over 1 minute, it's more probable that we will catch at least 1 heartbeat per minute rather than if it was produced, at the very end of the minute, then it's very prone to error. So let's assume that we are producing twice a minute. And we didn't need any development on the, actual microservice side. We just put a API, a gateway, and a Lambda where those microservices, the stations will ping. And front-end developers just applied, mechanism, every 30 seconds, just ping this place. This AWS gateway took upon those pings, and Lambda produced a message to the topic. Since we already have message to the topic, which contains the information about timestamp and the kitchen and maybe the workstation ID, we have what we want, right? We can aggregate, we can process, we can produce metrics. So this heartbeat contains only a kitchen info because we only need the resolution of kitchen. And statistically, if you think about it, if there is like people working in the kitchen, you will have all the time the same heartbeat, right? Because there is 20 workstations or 50 workstations open, so you will get like 40 or 100 heartbeats per minute, times 2, so 100, 200, okay? So this is constant. If you take a look at example, it's almost constant, but this is night, right? So for night, maybe some stations will be off, or maybe there is the whole kitchen is off. In this case, this is the one kitchen, right? So we have like 200 heartbeats per minute. For night, for most of the places, it's less. But as you can see, some kitchens are pretty much constant and they work 24/7, right? So for us, it's normal that we would have constant heartbeats. If we don't, then maybe we have a problem. So now, instead of looking at some dashboards, like trying to graph it, we can apply alerts. And what kind of alerts we can apply on those metrics that I mentioned here? First of all, the very good and very helpful alert is alerting or monitoring for rejected orders. So as I mentioned, basically a spike in rejected orders might mean something or might not. Depends. When, for example, if it's in a particular kitchen, in a particular place, for the same reason. And actually we did that, so we applied the condition if for a particular bucket of 10 minutes for the same aggregator, kitchen, and reason, we have more than 2 rejections, that's something alerting. And this way, as you can see, this is a spike for the same dimensions. We are able to tell quite fast because the gap is only 10 minutes. We can tell something is wrong. Then the alert gets sent on the Slack. People from command center pick it up, look into Dynatrace, call this place, and actually we are detecting business outages using this attitude. Another thing, what if there is opposite situation? We expect to get 15, 20, or maybe 10 orders per minute or per 5 minutes from some particular aggregator, and at some point of time we don't. It goes down, and it's basically like, patient's dead, right? At this point of time, like somewhere around, 11:20, we should not go to 0. If we go to 0, something's wrong. Again, this is not being monitored on some dashboard, but this is active alert that goes to Slack. Okay, so these people have to look basically what's going on, like command center is going to look what's going on and detect another outage, which is not related to system. It might be just the aggregator has some problems, right? We don't see any 400, 500 errors. Everything is okay on our side, but we are, lacking orders, right? Something's down. And this is another thing. The purple line here, as this is a heartbeat, as you know, pretty much it should be stable, especially at this point of time, which is like somewhere around evening. It shouldn't go to 0, but it went to 0, right? The purple line. Just as normal heartbeat, something is wrong, right? The patient is down again, or just patient is suffocating. So this patient was suffocating due to internal outage. Alert goes on Slack, they call the kitchen, and kitchen says, yeah, we have internet outage. Then they can react. They don't have to wait for complaints for customers. They can react. Okay, this kitchen has outage. We will close this kitchen. People will not be able to order from this kitchen. Of course, we are losing money in terms we are not getting orders, but we are saving the face, right? Which is sometimes even more important than, losing 100 or 1,000. And this is how it looks on Slack. So there is some, pre-made information from Dynatrace. I covered up the aggregator and reason, but the information that gets on Slack, there were 3 or more cancellations for aggregator X with this reason last 20 minutes. When they see that, they know what to do, they know what to check, where to go in Dynatrace. So takeaways, guys. First of all, system and operational metrics or business metrics are just different outlooks. If you are working with metrics right now, there is value that this kind of operational metrics that can be can bring to your company or to your support team or even to yourself. They have different outlook, different way of maybe implementing that, but the attitude is the same, right? You have some outage, some problem, and you need to do some RCA around it, and it helps you react faster, right? In this case, our business side or the command center, people who we were working with, like so kind of second line of support, they know their needs. They will come up, you just need to get into the rhythm, sit with them every week, slowly, gradually build up, listen to them and try to solve those problems or apply those solutions for them. This is not for me, this is not for you to even see the presentation, this is for them to gather from that. These people or people for whom you are providing this kind of solution, so more business-oriented, operation-oriented people, they will give you feedback. Just listen to them, just ask questions. Try to work with them closely. Try to maybe work on the same Jira, like on tickets or whatever they are using, right? Don't be the developer like somewhere outside. Just okay, what now? Okay, no, right? This will not work in this context. You don't know that. I don't know that. Like you don't know your business. Trust me. In this kind of things, even if you know more or less what's going on, you don't know what's going on, right? You need to listen closely. And few times during solving these problems, I came up with impossible problems. I came up with them. I asked the wrong question, Few times it was like, it cannot be done. Like, I don't know how to do it. Like, I've been thinking, like, going there, you know this feeling, like, okay, I will try tomorrow. And tomorrow, and 2 weeks of the same, right? You cannot solve this problem. Most likely, you are asking the wrong question. You are trying to solve the wrong problem. Like, go back to the start, ask the question again, and then you will find the proper answer. There is no impossible problems. And use what you have. If you already have data on Kafka, WebSockets, some other bus, even S3 files, you can use that for different purposes, like open your mind, okay? Thank you very much. I think I was below 50 minutes.